I guess it's working. All right, so here's the stuff from 7.1. These are our first 4 rules. I'm just going to kind of walk us through them, see if we can make some sense out of them so that you can use them in proofs. Starting with modus ponens. What modus ponens says is, if you have 2 true statements, if P then Q and P, then you can validly conclude Q. What that means, of course, is if the antecedent is true, then the consequent is true. That's how if-thens work, right? Well, this says the antecedent is true. Therefore, you can know that the consequent is true. So anytime you're doing one of these proofs, and you have an if-then statement, and somewhere else in one of the lines, you have the antecedent, then you can derive the consequent. If it is raining, then the ground is wet. It is raining. Well, therefore, then, the ground is wet. Valid conclusion, right? Modus tollens, same idea, works the other way around. You'll remember that with if-then statements, the antecedent expresses the sufficient condition, and the consequent expresses the necessary condition. Well, this says, if you don't have the necessary condition, then you don't have the other one either. If it's raining, then the ground is wet. But the ground isn't wet, then it's not raining. So again, in a proof, if you had an if-then statement and another line where the consequent of that statement is denied, then you can know, validly infer, that the antecedent is also false. So far, so good? I hope so. You're not here to answer. Hypothetical syllogism. This is sometimes called chain argument. The idea is that with 2 if-then statements, you'll notice that the consequent of this one is the antecedent of that one. And so the rule is we can kind of cancel these out, sort of, so to speak. I mean, you can't really cancel stuff out in logic, but that's kind of the net effect. This Q provides the link between the P and the R. So if we have the same term, the consequent of one, the antecedent of another, you can drop them and just put the rest of it together, right? The P stays the antecedent, the R stays the consequent, because they were held together by this chain, by this link in the chain, like Q. Like I said, sometimes this is called the chain connection. The idea being that if you have a middle term, not to confuse this with categorical syllogisms, but if you have a middle term, then they can sort of disappear and leave you with what's left. So if P then Q, if Q then R, therefore if P then R. If it's raining, then the ground is wet. If the ground is wet, we can't play golf. If it's raining, we can't play golf. Piece of cake, right? Finally then, last but not least in our hearts, disjunctive syllogism, which you see fairly frequently. You'll remember that in an or statement, in order for the or statement to be true, either one of its parts must be true. So what this says is, if you're given an or statement, P or Q, and you know that one of them is not true, well then the other one has to be true. Think of your truth tables again, right? In order for an or statement to be true, one of the parts must be true. So if you have an or statement and another statement that tells you one of these is not true, then the only option is it must be the other one. And that's how disjunctive syllogism works. When you find you're dealing with an or statement in one of these proofs, one thing to look for is the denial of one of these terms. If one of them is denied, then you are free to conclude the other. That's 7.1.